All right, so this video for today is going to be just like a review of everything that we did before spring break. I don't mean like the whole third quarter, but I mean like that week before. So I want to point out a couple things that I've done in our module 3 um, kind of unit so far. So here we go, right? So like I've got the notes that you had from module 3. These are the completed notes that I gave. You still have those. I'll also post a couple of the videos that I have in conjunction with this one. But I wanted to go to lesson 1. And I wanted to remind you that when we're working with identities, these are going to be the key ones that you really want to have down. And these are going to be the things that you want to have memorized. So if you remember them, great. If not, spend a little bit of time reviewing them, okay? It'll benefit you because the more you know them, then the easier your work will be. Because remember, we use these a lot for like substitution uh, and a few other things, or changing things to sines and cosines. So um, you're going to want to know those identities. All right, so at least those ones. I'll try to keep it to those ones. If there's any of these that pop up, you'll have them given to you. So um, these would be the 11 that you need to know. Okay, so those are there in OneNote still, but you've got completed notes for lesson 1 and lesson 2. So if you want to kind of go through those and see what we did again, and maybe look at your own notes and see how you kind of worked with those, that would be a good idea. But what I'm going to do right now is kind of go over a handful of things, all these different strategies that you can do to simplify a trig expression. And so we're going to do this today, and then tomorrow we're going to talk about more of the same. And it'll just be a lot of practicing over the next couple of days, and then we'll see how it goes. Okay. So when you're simplifying a trig expression, you're given this expression and you're just trying to make it simpler. And so one of the most common ways uh, to simplify a trig expression is through substitution. And so you look at the expression, you say, what's happening here? So you've got 2 times the cotangent of x times the sine of x, right? So you have like 3 things being multiplied. And so what I want to do is I want to substitute in something for one thing, or for maybe all the things, and I want to substitute in stuff that will then allow me to do simplification. Maybe that things will cancel out, right? So cotangent, if you remember, is cosine of x over sine of x. And then I'm going to keep this as sine of x, because that would be like sine of x over 1, and then these signs will reduce, right? Because when you have sine divided by sine, it would just reduce to 1. And so then we're left with 2 cosine of x, okay? And so there is substitution. There's lots of ways substitution can work. We'll see it pop up as we go through some more of the examples, but it happens, okay? Another way is factoring, right? So if we take a look at this, this is a difference of squares scenario, right? So like a squared minus b squared, right? Even though it's to the 4th, but the idea, remember, we get conjugates. So like a plus b and a minus b. And so in this case, this would be sine squared of x minus cosine squared, and sine squared of x plus cosine squared. And then we ask ourselves, can we keep going, right? The whole point of factoring is to make life better and see if I can keep going. And if you have remembered some of these things, this one right here is something. So if you go back and look at the notes from day 1, and you look at the different identities, sine squared plus cosine squared is just 1. Sine squared minus cosine squared is nothing. But sine squared minus cosine squared times 1 can just be simplified to sine squared minus cosine squared. Oops, I've got my x. Don't forget the x, remember that's bad. I've got to have that angle in there. So sine squared of x minus cosine squared of x would be the answer there. All right, so we can do multiplication. Multiplication is pretty straightforward. If you see things multiply together, then just multiply them and then see where it takes you, right? So cosecant times cosecant would be cosecant squared. That times that would be plus cosecant. -1 times that would be minus cosecant. And then -1 times 1 would be -1. So the middle terms cancel out because they were conjugates. So cosecant squared of x minus 1. And then you actually have to go look. So if you recall, if you go look at that one page with the identities, it's 1 plus cotangent squared of x equals cosecant squared of x. And we said that the Pythagorean identities, they're movable. So you can move them around. I don't even know if that's the right spelling, but or if movable is a word. But we said that you can move these terms around using basic algebra to make it look like what you want. So I'm going to subtract 1. And so I've got cotangent squared equals cosecant squared minus 1. And so cosecant squared minus 1 can be substituted, and we can put in cotangent squared of x. And that's our answer right there. Okay. You may be saying to yourself at this moment, you're like, yo, dude, this stay-at-home order quarantine, I am not able to follow you. I do think if you watch this video maybe once, go watch my other video, and then also go back and look at some of your work and practice. It will help. And just ask me questions. These are really easy ones to answer questions through. So send me questions and I can send you back some helpful kind of tips and things. So another thing you can do is you can multiply by the reciprocal. Right, remember if you have just x, then the reciprocal of x is 1 over x. So I want to point out something that you can do here, right? So like tangent is sine of x over cosine of x. So you get like a fraction on top. So that's what that becomes. But then, right, because where am I getting this multiplied by the reciprocal? Secant is 1 over cosine of x. And so now you have another fraction. So the reason I'm saying multiply by the reciprocal is because when you have one fraction on the numerator divided by another fraction on the denominator, you multiply by the reciprocal. So you multiply by cosine of x over 1, right? And that's what you would multiply on top and bottom. Or excuse me, not on top and bottom, but you would flip it and multiply to the top. And now the cosine is reduced, and it leaves you with just, sine of x, okay? So when you're dividing fractions, you multiply by the reciprocal, right? So when dividing, oh my word, fractions, okay? Then you would multiply by the reciprocal. Then we got a few more, kind of idea. But one of the things you can do is you can multiply by the conjugate. So remember the conjugate, if you have a plus b, then the conjugate of a plus b is a minus b, and vice versa, right? So if you have a minus b, then the conjugate is a plus b. And so multiplying by the conjugate, let me remind you, you would like to multiply by the conjugate so that, right, for the purpose of, right, so that you can get to a Pythagorean identity. Okay, really the only time we multiply by the conjugate is so that we can get to a Pythagorean identity. If you don't get to a Pythagorean identity, either you multiplied wrong or you just shouldn't have multiplied by the conjugate at all. But let me show you, right? So multiply by the conjugate, what you do to the bottom you have to do the top, so 1 plus sine of x, okay? And so on top, we would get cosine, and I'm not going to distribute because sometimes that clutters up the problem. I'm just going to write cosine times 1 plus sine of x over, and then if you multiply this out, 1 times 1 is 1. You get a plus sine x and a minus sine x. Those would cancel, and then minus sine squared. And so what I'm saying is the reason this is good that you got 1 minus sine squared on the bottom, because if I go off to the side over here, don't do this in the work, but sine squared of x plus cosine squared of x equals 1. But if I move this over to the other side, I'd get cosine squared equals 1 minus sine squared. And so we can say that 1 minus sine squared is just cosine squared. So cosine of x times 1 plus sine of x all over cosine squared. And so then cosines can reduce. And so you get 1 plus sine over cosine. Okay. And so multiplying by a conjugate should lead to this idea over here. It should lead to a Pythagorean identity. If it doesn't, you just made the problem messier for not too many good reasons. So like, for example, here, sometimes people will look at this problem that I've got here and they'll say, you know what, guys, we should multiply by the conjugate. It's a good idea. It could work, but it won't work. Okay, you could do multiply by tangent minus cotangent. All it's going to do is make the problem gross. So we're not going to do that. One thing that always works, but it's never the best thing. It's like, okay, I shouldn't say never the best thing. It is sometimes the best thing. It works fine, but it can make the problem really long. So, but it works, and it's a good strategy, especially if you don't remember a lot of stuff. So one of the things is you can change everything into sines and cosines. So like tangent can become sine of x over cosine of x. And then tangent is also sine of x over cosine of x. Plus, and then you have cosine of x over sine of x, okay? And so what happens is you turn everything into sines and cosines, and then you kind of let the problem tell you what you got to do. So from here, in order to multiply by the reciprocal, because you have fractions on top and bottom, you need one fraction on the bottom. So we got to get a common denominator. So I'm going to multiply this by sine. And I'm going to multiply this by cosine. And so then I'd have sine squared over cosine x sine of x plus cosine squared over cosine x sine of x. And if you're with me, sine squared plus cosine squared is, on the count of 3, 1, 2, 3, 1. So you have 1 over cosine of x sine of x. So this is the fraction that would be on the bottom. And when you divide fractions, what do? You multiply by the reciprocal. So cosine of x sine of x over 1 is your new problem, and the cosines would reduce. And this whole thing just leaves you with what? Sine squared. Okay, sine squared. So a couple of things, right? The cosines would reduce, yeah. So a couple things about doing work. I just want to remind you, work down, okay? That's always the best thing, work down. And then also don't forget that when you write sine, cosine, tangent, cosecant, secant, cotangent, all those things, make sure that you are putting the variable with it. Because remember, the variable represents the angle, and it would make no sense if you didn't write the variable, okay? So make sure that you're putting that in throughout the whole problem. Don't just put it in at like the beginning or end, like some people have done. Now, this was messy. I want to point out one thing for this problem that is allowed, and it's not in my notes, but I want to add one more. You can multiply by 1. Multiplying by 1 is a strategy. Now, what do you mean multiply by 1? I mean that when you multiply by 1, you keep, so like take for example, I don't know, say like a squared b over c. Like say you have something wacky like this. If I multiply this by 1 times 1, what does it become? Stays the same, a squared b over c. Like the value doesn't change. It is what it is because multiplying by 1 doesn't change the value. But what you can do is you can multiply by 1, and not just 1, but you can multiply by what I like to call a fancy one. Like say you wanted c squared on the bottom. Well, if I multiply c on the bottom and c on top, what's c divided by c? C divided by c, this whole thing right there is 1, but now the problem is going to look different. It's going to be a squared bc over c squared, and the value is still the same, but it looks different. So like, for example, in the problem we had up above, tangent of theta over tangent of theta plus cotangent of theta, and this just takes practice, you can essentially multiply by 1. So in my mind, I'm thinking, let's multiply by tangent of theta, okay? And you say, well, why would you do that? And so let me tell you. So I'm going to multiply by tangent of theta on top and bottom, right? So this right here, what am I doing? I'm multiplying by 1, right? Tangent over tangent is 1. But this gets really easy if you start to look at this. The reason I chose tangent is because tangent times cotangent is 1, and tangent times tangent is tangent squared. And I know that tangent squared of theta plus 1 is a Pythagorean identity. So I was thinking like, man, if I can multiply by something that would get me to a Pythagorean identity, that could be nice. So I multiply by tangent. Then on top, I get tangent squared. The tangent squareds don't cancel out, but like I said, tangent squared plus 1 is a Pythagorean identity. It's this. Tangent squared of theta plus 1 equals secant squared. Okay. And so then I can call this tangent squared of theta over secant squared. And then from there, we can maybe turn it into sines and cosines, so like sine squared of theta over cosine squared, all over 1 over cosine squared, multiply by the reciprocal, cosine squared of theta over 1, cosine squareds cancel out, leaves you with sine squared. It's just another way of doing the problem. It's not the best way. It just is a way. So I wanted to add that in, that you can multiply by a fancy 1, right, whenever you want to. And you literally can do it anytime. And if it helps you in the problem, great. Okay. So that's that. I hope you guys remember a little bit about identities. And we'll keep practicing over the next 3-4 days. So have a great day, and talk to you later.